So this is a first for me. I got some gifts. Well, okay. Second time getting gifts. Second person. Actually, I don't know if the first person maybe got me the first gift also. So I guess we'll call the series Gift Box. I mean, I know some other guys call it mail time or mailbox time. I don't know. So first I can show you these, which were my first gift. Awesome to whoever gave it to me. Again, sorry, I don't know who. You can focus on, yes, focus on that. Now you can track closer. So these are actually mini bolt cutters. I thought they were side cutters. They're mini bolt cutters. And I got this gift box. There's actually two different gifts. Get rid of that. I'll cover your last name because I don't know if you want to be anonymous. So thanks, Trent. And here's some stuff that I had on my Amazon wish list that I couldn't really justify buying myself. But, you know, if you guys want to buy me stuff, I'm not complaining. First is a compact size, less weight battery, because I do a lot of trips up the hill with my drill. And I'll go get one. When I first got my first Makita set, probably 3 years ago, it came with two of these 5 amp hour batteries. Focus there. And they last forever, but they're heavy. And for a lot of things, these are well, they're a pain in the butt. I've always wanted a smaller battery, but I couldn't justify getting a smaller battery just for the sake of the convenience. But this is a much smaller, lighter battery. Let me take it out of the package. And that's why I have tin snips in my bag. Graceful. Perfect. Get those later. So here we can see that this one is easily half the weight. So there's a few things that these are good for that I can think of. Operation of a circular saw like this. They last a fairly long time, and in this case, most of your use is going to be flat on a board or something. So you're not actually carrying it around, and you need the extra power and torque and lifespan of these. But other things, like other high power things that use the big battery nicely, is like a battery powered angle grinder. So the first two Makita products I bought were these as a pair with two of the 5 amp hour batteries and a charger. And this guy is fairly light, but you add the 5 amp hour battery and it's like double the weight. So this it can be tiring. This would not be tiring, although it appears to be dead. So I have to charge it first. Another thing that the lightweight battery would be beneficial on is these set of hedge trimmers. If you're doing a lot of hedges, your arm will wear out before the battery dies. These batteries. So a lightweight battery will be beneficial for the use of this guy too. Let's get these out of the way because I think we're done with the battery. Just make sure that at the end of the video it does work after it's charged up. You guys are reasonably out of the frame. Good. Next up in here we have, this was a separate package. Actually, this box is all one thing, and then this was a separate package. This is another ball valve. So for my hydro turbine, I'm going to have probably 3 of these and the spear valve on my hydro turbine. This will just be one less thing that I have to buy. Thanks, Trent. We also have a Rode Video Micro. This is actually Rode Video Micro number 2 for me. I have one on the camera right now that you guys are hearing me through. The problem with that is every time that I switch from in front of the camera like this or behind the camera, if I'm, pointing at something and talking, I have to spin the microphone around. So now I got a second microphone. I can plug them in with an adapter so that my right channel is front and left channel is back, or vice versa. And then I can just not mess with the microphone and select which one I want to be heard on the video. So this will save me a lot of time at the expense of weight. So I may leave this at home for a lot of the time. Actually, some of the times that I go up the hill, I just strip my camera bare and I don't take the microphone or the cage that's on it, just so it's lighter and smaller. But this will be fantastic down around the house. The only other thing in here is a Stylo multi-purpose supply organizer. This is an organizer for the workbench here that I'm on. And I saw this on Reddit. There's a Reddit subreddit called Workbenches. Reddit.com/r/workbenches. This was one of the things that somebody else had on their workbench that I thought was really nifty. And it goes along with my first order retrievability tool bag that's over there, so I can, access everything pretty easily. And then if I need anything in here, I can just grab and go. But sometimes stuff is good on the desk, but not necessarily in the tool bag. Like, say I had a nice mechanical pencil. I could put it in a drawer down here, but it will be more accessible if it's on my desk surface. So I can put all sorts of organization stuff in there. Just throw some extra pens in there, pencils. Let me look at that post and see what else he had on there. Maybe I can get some ideas. The only other things I saw from his post that would really be fitting in here are zip ties. So I'm going to put some zip ties in there, just a few loose ones. You can always have them handy, that's always useful. And Sharpies. I have a whole bunch of extra USB cables. I'm always needing extra ones. So I'm going to throw in, well, this one's a printer cable, not that that's necessarily super useful. I know some things like Arduinos can use them. And I do have an Arduino or a micro USB. So they'll go in there too. Easy access when I need them. And I have a USB charger plugged into my desk here already. So I can just grab these and use them as needed. Do you have any smaller black ones? I guess I'll put some of these really tiny black ones in there too, because they can be useful in their own right. If you were interested, here's what's in my zip tie container. Just a bunch of different zip ties, and then I also have these Velcro straps in here, so that's what those are if you were curious. And then this goes in my tub storage system. I grabbed an Ethernet cable too, just because I do have some IT responsibilities in my job that sometimes comes home. So that'll be useful for diagnosing stuff too, because I do bring my laptop down here and work on my workbench sometimes. Let's go see if that battery's got some charge in it. All right, it's sat on the charger for a good 10 minutes. We'll see what it does. Yes, there we are. So one of these is full too. These last for so long that I can use them for a full day of working, just random stuff, and they'll still show full. Now, even though this is a smaller battery, it will run larger tools. Like the circular saw, it just won't have as much power or life. I guess one nice thing about the big batteries is the center of gravity is really low, so they're more stable. But then again, this one's shorter, so it's also more stable. So I guess that's not a neither here nor there. Thank you very much, Trent, and everybody else who supports this channel, either by visiting my Amazon links of recommended, suggested things down below, or, there's a wish list that I have there. Clearly, I have to update it a little bit because people are looking at it and buying me things off of it. So I want to make sure that it is relevant. And I also want to thank all my Patreon supporters. You guys are fantastic. You guys are buying a lot of tools to complete this project and materials, really. I guess since you're here, I can show you what your support is funding for this project. This is something I got a few months ago. This company makes and sells alternators and motors for all sorts of purposes. And if you've watched Chris Harbor's channel, this may look familiar. Let me zoom out a little bit for you guys so you can see. This is the alternator that I intend to run on my turbine. It is what's called an outrunner permanent magnet 3-phase wild AC generator. So on the back side here, it has a bunch of coils that are wired up as a 3-phase generator. And around the perimeter here, there are permanent magnets. As the outside spins, it goes over the magnets, which generates a current and voltage in the coils, which will then go through these 3 wires to a 3-phase rectifier to make DC power. And then it has a cooling fan on top. I didn't realize that. It has vent holes down to the stator. So that's where a lot of the airflow will come through this fan to cool off the stator coils that are underneath and not rotating. So normally they wouldn't get a whole lot of airflow, but in this orientation they do. And then it also has a shaft adapter that will go in here, and then you mount your turbine runner to this. I do not have that yet. I have not selected which spoons I'm using with this. I'm not even entirely sure that this is the generator that I'm going to be using. So I'm just looking it up here on their website. You can pause and look at that if you want. I don't know how volts AC correlates to volts DC after it's rectified. One of you might know, just tell me in the comments. I'm also noticing here that that's not good. So that'll all need cut off. That's not good. So if this is spinning at 2,500 RPMs at 48 volts AC, I do want to run a 48 volt system because I'm expecting it to be a fairly high power, higher... Geez, quiet down up there. The way you want to size these is, say you have a charge controller that's rated for 150 volts. That's a commonly rated charge controller. You'd want your generator to generate less volts unloaded than the maximum of your charge controller so you don't blow it out. If you don't have any load on your wires, then it's going to spin twice as fast as the optimally loaded condition for your generator. So if it's spinning twice as fast, it's going to be twice the voltage of your operating voltage / RPM. And for efficiency's sake, you want your operating voltage, your loaded voltage, to be as high as you can. And then your charge controller will decrease the voltage down to your batteries, which would be the most efficient method. I guess the long and the short of it is I'm concerned that I'll need to be spinning this generator at like 4,000 RPMs to get the voltage that I want. And that's kind of fast. So I might have selected the wrong generator for my application. I bought this many months ago before I really knew a whole lot about it. I just thought, oh, it's rated for 48 volts, and that should be what I need to use. Maybe not. These are some other options that I have. This is a wind blue alternator. It's based on a 10SI GM alternator or a 12SI, I'm not sure which. It's a DC 520 that they make. And it's kind of the inverse of this, whereas the magnet is spinning inside and the coils are outside. So I don't know if this is going to be the right... I'm not even sure if this would be a better option than this. I bought this for wind turbine experiments, which I haven't had any time to work on because I've been focusing all my time on this hydro turbine system. So this is just another thing that I've bought with proceeds. Just haven't gone around to it yet. This is the generator that's off my water wheel, and it's only rated at 1.5 amps. I'm not sure what the amps are, the amp rating of this is, but 1.5 amps at 48 volts, which is what I'm planning on running things at, that's only 72 watts. So that's what this 72 watt permanent magnet DC motor would be good for. This motor is kind of the inverse of this here, in that the magnets are on the outside, so there has to be brushes. That's what these are here, brushes to commutate the electrical signal from the wire to the coils inside that are spinning. I'll have more of my selections or engineering, or if I do have any questions that I need to ask the community, those will be a separate video. So I guess that's it for this video. I just gave you a little bit of extra content at the end because I figure that you guys deserve it. So there it is. Like, comment, subscribe, Amazon, Patreon, PayPal. I guess there's some more bonus content. This is a hoverboard motor, and it's also a three-phase motor. It's outrunner type that's most similar to the Mote Energy one that I already put away in a box. And so this is a three-phase bridge rectifier. You put three-phase wild AC into it and you get DC out of it, which is also the exact same thing that's inside of this guy. All car alternators have a three-phase bridge rectifier in it, but car alternators are meant to spin a lot faster RPM, and this actually generates quite a bit of voltage at a lower RPM. So I have it connected up to the battery pin and then the ground here, and then that goes up to, this is an MPPT, a little bit dusty, charge controller. And then, well, normally you'd have a load here, but this is only good for 10 amps, and the inrush current on this is more than 10 amps. So I have this inverter. This is a pure sine wave inverter hooked up directly to the battery, and right now it's running off of the battery, this light, as an inverter. We can see this smart solar thing here is connected through Bluetooth. See that little icon there? It's Bluetooth. I wonder why it's beeping. Maybe it's a low voltage alarm. Yeah, that voltage is decreasing. Let's get this going. Shut this off. It's interesting to see because this is a automatic load controller that will draw as much current as it can to achieve the right voltage. It'll put a load on whatever your alternator or solar panels are. And this has a automatic controller of sorts in it too. It's like a governor on an engine that if you're requesting a lot of RPM but the RPM decreases, it gives it more juice. So it's kind of those two things fighting each other. That's why you saw the watts that it was generating going up and down. So just an interesting thing to see there at the end. So this would be good with an RPM gauge to determine what sort of, since I have it, I'll show it to you guys. This is my RPM gauge, another one of those purchases that I've made thanks to you guys. Link in the description if you're interested. So this comes with reflective tape, and I've put the reflective tape on this nut here so we can see with a bunch of data gathering equipment here, we can see the voltage profile of this guy. I guess I'm going to have to set the tripod up. Now we can see what it does without load and with a load to see if the voltage is variable depending on the load, which is something that I've always been curious about. That is not 3,000 RPMs. I think that it doesn't like that because it's reflective. Let me fix that. Not so reflective now, are you? Let's try this again. Now we'll try it unloaded. So now I have disconnected my automatic charge controller, so we can't go off of that. We'll have to go off of this voltmeter. We'll get another speed reading too. Okay, that was pretty stable. Now we'll see if it has generated the same volts per RPM under load versus not loaded, which is something that I've always been curious and somewhat concerned about. So that'll be a good data point for me. I guess because we're here also, an interesting thing about these is it has a jump out for three-phase, so bypassing the inbuilt thing. So we'll see what sort of voltage we get on that. So this voltage is 2 of the 3 phases in AC. So that'll give us some interesting data too.
And here's the data I threw together in the spreadsheet. The main thing I wanted to look at here was the voltage drop between loaded and unloaded. You can see there's about a 20% drop there. Also, I wanted to see how it would behave with other RPMs and types of voltage. So we have the full RPM and the partial RPM here, and we can see the volts per RPM is almost identical. We'll just call them the same. And then there's a similar calculation for 2 of the 3 wires, so the voltage of 1 phase. And so this would be the voltage of 1 phase, and there's a little bit of math to get the sum of the voltages. Short of it is it's 1.5 times this, but there's a little bit extra too, so you have 3 times the rectifier drop because there's 3 phases. Because there's 3 phases, and you have 0.7 volts per rectifier drop. So I think that's how it works. And this is voltage that we get. So I use this voltage and this volt per RPM thing. We see there's a little bit extra voltage drop compared to straight off of the 3-phase, but that might just be my calculations being a little bit wrong. In the future, I'm going to have other data from both this alternator and other alternators that I have, and I'll try to get a little bit more of a fixed RPM source running them. My drill is a little bit variable in its RPM, which is not ideal for this testing. And then also I want to get lower RPM results for this as a loaded DC. So you see that that's missing. It should go like here. And that's all.
Goodbye.